Hey guys, hope y'all are doing well. This video is made for anyone that was absent on the day when we were doing arithmetic sequences and their word problems. Okay, so this video will cover those notes. So to start off with, I just want you to look at these, pause the video, and find the next three terms in these sequences. Okay, so pause the video. All right, so hopefully in this one you notice that we are just adding 3 each time. And so each time we're going up by 3, so that should be 21, 24, 27. This one it appears that we are going down by 4 each time, so negative 21, negative 25, and negative 29. This one, it appears something weird is going on, right? We're going up by 1 and then down 3 and up by 1 and then down 3 and then up by 1, down 3. So we should be going up by 1 again, but then down 3 and then up by 1 and so on and so forth, right? Okay. This one, it appeared that we were adding 4 each time. So we got 65, 69, 73, right? Okay. So I'll let y'all pause this video and take some time to write these notes, and then we're going to take some time to talk about it. All right, so a sequence is just an ordered list of numbers. So basically any numbers that have a set order, and we can see that pattern going is a sequence, right? And a term is each specific number in the sequence. Now today we're going to be talking about arithmetic sequences. Okay, this word arithmetic, you'll often think like arithmetic when you see it, because these numbers, we're adding something each time. In other words, they have a common difference called the. How we find that is we can subtract 1 from the previous one, and sometimes it's even super easy just to spot it, right? To see what it's changing by each time. Okay. The common difference is called the slope of an arithmetic sequence. It's what we're adding or subtracting, right? Okay, so here's some terminology that we need to know. So the terms of a sequence, are represented by a sub n, where n is the index. In other words, the position of the term in the sequence. So this is our first term, right? Second term, third term, fourth term. So when we say a sub 1, that's our first term, so it's 3. A sub 2, our second term, 5. A sub 3, third term, 7, so on and so forth, right? So when we say a sub 1, first term, if we said a sub 45, that'd be the 45th term, okay? So all arithmetic sequences are linear functions, okay? So x is the n, so that's going to be our x variable going down through here. Y is the a sub n. Right, so the number in the sequence. Okay, so with our 3, 5, 7, 9, right, that was our 3, 5, 7, 9. Those will be our y's. And our n's, in other words, if it was the first one, the second one, the third one, the fourth one, will be our x's. So 1, 2, 3, 4. Now let's plot those, and we should see a linear pattern. So I'm at 1, 3, so I'm at 1, 3 right here. If it'll let me draw it, 1, 3. 2, 5, so right up in here, 3, 7, so right there, followed by 4, 9, so up here. It really doesn't like me drawing those, apparently. So we can draw a linear function up through it, right? So we just keep going, and if we went backwards, we go back through here, so on and so forth, right? Okay, so they will always represent linear functions. Okay, so we are to generate some arithmetic sequences using the following criteria. So the first term is 2, the difference is 3, we need to write the first 6. So it says the first term is 2, the difference is 3. In other words, we're adding 3 each time. So 2, 5, 8, 11, 14, let's see, keep going, right? So 17, 20, I think that's our first 6, 2, 3, 4, 5, 6, 7, oops, so 17, 20, right? We just keep going like that. Okay, so the first term is 0, the difference is 0.5, so we got 0, 0.5, 1, 1.5, 2, 2.5, 3, right? We just keep going. So 1, 2, 3, 4, 5, 6, 7, one more, 8. The first term is -1, the difference is -2. Ooh, look, -2 is our difference. That means we're going down, right? So -1, -3, -5, -7, -9, and so on, right? Okay, so pretty easy, hopefully, just to make those sequences. Now, we have something called the explicit or closed formula, okay? So the idea of it is it's a rule for calculating a particular term in the sequence, okay? Here it is, and it is like the best thing ever, okay? So here is your explicit formula. A sub n equals a sub 1 plus d times n minus 1. Now, these are really, really, really important right here, okay? You need to know what these represent. Otherwise, that formula doesn't make any sense, right? A sub n, right, is our term, and that n is just the term number. So if I want the 56th term, 56 is my n. A sub 1 is the first term, d is the common difference, okay? You'll occasionally see it simplified to this, but all this is, right, is us distributing and simplifying a bit, okay? So that's all that is. Typically, you will see this one, okay? Now, there's something called the recursive formula, and the recursive formula is less helpful, but you'll often be asked to write it out. And basically, you just tell it, what is the first term? And then you tell it, we're adding this common difference each time, okay? So that's all you tell the recursive formula. Now, on your formula sheet, right, these look a smidgen different, okay? This one looks exactly the same. Your D is switched on your explicit formula to the back. That's okay. You can still distribute from there, okay? But on this one, okay, it doesn't note that we need an A sub 1. So you have to remember to put that A sub 1 with it, okay? So let's do this one. So we have to figure out first if we think it's arithmetic. In other words, we have to see if we think it's adding the same thing every time. So let's check it out. This one looks like 7, 7 more, 7 more. Oh, it appears to be arithmetic. So yes, yay. Okay. Then the closed or explicit formula. Okay, so it's a sub n equals a sub 1 plus n minus 1 times d. So a sub n, we don't plug in anything for that. So just regular old a sub n equals a sub 1. Okay, so a sub 1 is our first term. So first term was 15 plus n minus 1. So n minus 1 times our common difference. We're adding 7 each time, so that will be 7. Okay. Then with the recursive formula, remember that each time we have to say what a sub 1 is. So a sub 1 is 15, and then we can just get the rest of it from over here. Okay. And notice that d is all we're plugging in. So we can say a sub n equals a sub n minus 1 plus d, so plus 7. Now guys, it wants us to find a sub 48. That's cool and all, but with that 48, in order to use the recursive formula, we'd have to know a sub 47, and I don't want to count up that many times. So how we get away from doing that is we plug it into the explicit formula, okay? So what that means is we can plug in 48. Notice it's in the spot of n, so let's plug it in for n. So a sub 48 equals 15 plus n minus 1, so 48 minus 1 times 7. Okay, you can plug this whole side right here into your calculator, or you can reduce a little bit, make it 15 plus 47 times 7. Okay, however you want to. Go ahead and plug that into your calculator. When I plugged mine in, I got 344. So that means 344 is my a sub 48, which means my 48th term. Okay. All right. Let's check out this one. So let's see first if we think it is arithmetic or not. So looks like I'm going down here, down here, down here by 3 each time. Okay, we're going down by 3 each time. Yep, it is arithmetic. Okay, so we're then asked to write the explicit formula. Here it is again down here. Okay, and so I'm going to just plug some stuff in. A sub n equals a sub 1, so that's 15 plus n minus 1 times our common difference. This time it is 3, but we were going down each time, right? So we should actually say negative 3, okay? So that's getting multiplied by negative 3, okay? And there's our explicit formula. Remember, for the recursive, we have to say what a sub 1 is. So a sub 1 is 15. And then we can plug it in straight into this over here, okay? So a sub n equals our a sub n minus 1 plus d. This time our d is negative, so plus negative 3, or simply minus 3. We're asked to find a sub 25. It's going to be much easier with the explicit. So plug it in. A sub 25, 25 is our n. So we got 15 plus n minus 1. So 25 minus 1 times negative 3. I personally am expecting this to probably be a pretty big negative number, since right here we're multiplying 24 times negative 3. So let's see what we get. Plug that in your calculator. I got negative 57. And so a sub 25 equals negative 57. All right, guys. I see this sequence. What do y'all think is happening? It really, to me, looks like, well, we're adding 20 there, but we're adding 60 there. We're adding a bunch there. It looks like 180. So what we added each time almost tripled, right? I think it did triple. So with that happening, is that arithmetic? No, we're not adding something the same each time. Okay, we're going to get into this kind second semester, but for now, we can say bye-bye. Don't have to do this one because you are not arithmetic. Okay, so then there's this one. I would like for you to try this one out on your own, and then unpause the video and I will show you the solutions. All right, here is what we got. Check it out, see if you agree. All right, message your teacher with questions on that one. Now, let's look at this one, and then we will do some other stuff. Okay, so first off is this one, arithmetic. It appears that we are adding 5 each time. And so it sounds like it should be arithmetic. Let's write our explicit formula. So a sub n equals a sub 1, so that's negative 3, plus n minus 1, so n minus 1, times our common difference of 5. Recursive, remember we have to say a sub 1, which is negative 3. After that, we'll plug it in here. So a sub n equals a sub n minus 1 plus d, so plus common difference of 5. Next, we're going to find a sub 30. And with a sub 30, we know that we should use the explicit formula. So that'll be a sub 30 with 30 being our n, negative 3 plus n minus 1. So 30 minus 1, I'm going to go ahead and call that 29 times 5, and go ahead and plug that into your calculator. I personally got 142. Okay, so that means our 30th term is 142. All right, we're going to start moving towards some word problems. Okay, so here's a little bit of a review. Remember these from Unit 1, right? Terms are just the parts of a polynomial separated by a plus minus. Variables are the unknowns. Coefficients are numbers in front of a variable, and constants are numbers without a variable. Okay, so let's look at this thing. So in the first month, Ms. Thomas paid 25 cents per minute plus a startup cost of $125.32. Below is the expression that can be used to represent the cost of the first month. Okay, so she's paying something, sounds like by the minute. Here we have this equation. So first off, how many terms there are? Well, we can see them right here and right here. There's 2, separated by that plus sign. The constant, remember, does not have a variable, so we got 125.32. What does that constant represent? Well, that was our startup cost. What is the variable? Well, I see this m, and it said that it was per minute. So minutes. What is the coefficient? Remember, that's the numbers in front of the variable, so the 0.25, and that represents 25 cents. Okay. So to make money this summer, Charles cut grass for $20 a yard and painted fences for $30 a fence. He made $350 over the summer. The equation 20y plus 30f equals 350 represents Charles's money. So how many terms are there? Well, let's look at it. So we got this one, and then we have what they equal to. What they equal to is more like our sum. So we're just going to count these two as our terms. And then we end up with this constant on the other side, right? We know how much money he ended up making, right? And really on this one, guys, we kind of had to /3 since this one's on the other side of the equal sign, to be clear. The constant is 350. That's total money, right? The variables are y and f. And those are yards and fences. Yards and fences. So then the coefficients. Okay, we have a 20 and we have a 30. And those are representing 20 per yard and 30 per fence. And of course, this is money. I'm going to put my dollar signs. Boom. Okay. So throughout these next few problems, you're going to hit a lot of words that are going to feel very mathy. And I want you to come back to this part on your notes and fill in some words as you're going that you think sound like addition, subtraction, multiplication, division words. Okay? So here is what we're going to be doing to begin with. So in these word problems, let's look for a common difference being used between each term. Okay? So let's figure out which situation has a common difference. So the height of a plant grows 2 inches every day. Okay? So if it's growing 2 inches every day, it could be like 8 inches and 10 inches and 12 inches and 14, so on. So I think, yes, this one does. The cost of a video game increases by 10% each month. All right, let's say it's $50, right? 10% of 50 would make it $5, so $5 more than next month. Okay, so $55 that next month. Then after that, well, 10% of 55 is $5.50, so that would actually be $60.50. So no, not quite. So let's think about this money that Johnny's getting. $5 each week, so he'd have $5 first one, 10 total the next one, 15 and so on, right? So yeah, that one seems legit. So here is how we're going to solve word problems with an arithmetic sequence. Okay, table is going to be helpful. So make a table. And I'll let y'all write this and then unpause so I'll talk some more about them. So make a table, find the common difference in the first term, figure out which would be good. Remember, the recursive formula actually helps us get the next term given a previous term. The explicit helps us get anything. Okay, so then we plug our D and our A sub 1 in, then evaluate the formula and see if our answer actually makes sense. Okay, so let's do some. So you visit the Grand Canyon and drop a penny off the edge of a cliff. The distance the penny will fall is 16 feet the first second, 48 the next, 80 the third, and so on, and it says it's an arithmetic sequence. What is the total distance the object will fall in 6 seconds? All right, so let's think about this one a little bit. Our first thing was to make a table. Okay, so let's make a table.
Please release car riders and car drivers at this time.
So making our table, and as y'all could hear, Mr. Mercer just was talking up a storm on the announcements, and my pen seems to be glitching. See if I can fix it. Okay, I fixed it. So here is our table. So the first second, we have 16 feet. Second one, 48. Third one, 80. Fourth one, well, what do we seem to be going up by? We seem to be going up by 32 each time, right? So the next one we could guess after 80 would probably be 32 more, so 112, right? So after we make our table, It says to determine the common difference in the first term. Well, I think we kind of already did, right? We're adding 32 each time. Our first term is 16. And then we're going to figure out which formula we think would be better. We're going to evaluate it, and we're going to see if it actually makes sense. Now, with this one, we're only trying to go to the sixth term. Okay? We already have the first four, so I actually think this would be a good opportunity to use the recursive. Okay? We know that it is just a sub n equals a sub n minus 1. Let me fix this. A sub n minus 1 plus our common difference. Now, that said, we kind of did it in our heads, right? We're just saying it's the previous one plus 32. So if we go to the fifth one, okay, we're just doing 112 plus 32, which is 144. And then after that, it's really just a sub 6 equals a sub 5, which we already found out is 144, plus 32. So I'm going to plug it in. A sub 6 equals 144 plus 32. And let's see what we get. I got that 176 feet. Okay, and so that is how far it will have fallen after 6 seconds. All right, so Tom just bought a new cactus plant for his office. The cactus is currently 3 inches tall and will grow 2 inches every month. How tall will the cactus be after 14 months? Okay, here's an important note. When he got the cactus, right, so after 0 months have passed, the plant began at 3 inches tall. So that's actually our 0 term. Okay, so 0 was 3, 1 would be at 5, 2 would be at 7, so on and so forth. Okay, so let's figure out our a sub 1. After 1 month, it grew 2 inches, so 5 inches. Our common difference is 2 inches every month. Okay, and we want to figure out after 14 months. Well, that's a lot of writing out to do. So I think this would be a better spot for the explicit formula. So remember, that's a sub n equals a sub 1 plus n minus 1 times d. Okay, I'm going to make this formula. So our first term was 5. That's after 1 month, the plant was 5 inches tall. N minus 1 times our common difference. Okay, our common difference is 2 inches every month. Okay, and so then we know that we're trying to find after 14 months. So 14's our n, so let's plug it in. A sub 14 equals 5 plus 14 minus 1, right? 14 minus 1, so 13 times 2. And I feel like this cactus is getting really, really big. Okay, so 30 times 2, 26 plus 5, 31 inches tall. That's a really tall cactus. That is after 14 months. All right. The bell rang for the end of the day. I don't know if y'all can hear it on there. All right, so we got this person named Kayla, and she's starting with $25 in her allowance account. Each week that she does her chores, she receives $10 from her parents. Assuming she does not spend any money, how much money will Kayla have saved after 18 weeks? Okay, let's start with that question. Okay, so let's make this little table. So after 0 weeks, she has $25. After 1 week, if she did her chores, assuming she did, we have 35. 2, we have 45, so on and so forth, right? So first off, let's write down what we need. Our a sub 1 is 35. That's how much money she's got after 1 week. Our d, or our common difference, she's making $10 each week. Okay, so let's go ahead and make our explicit formula. A sub n equals a sub 1 plus n minus 1 times d. Okay, so our a sub n equals 35 for a sub 1 plus n minus 1 times common difference of 10. Okay, we want to know after 18 weeks. So 18 is our n, so a sub 18 equals 35 plus 18 minus 1, so 17 times 10. Okay, so 35 plus 170. Okay, so I'm getting that she would have $205 at that point. All right, second part of this problem. How many weeks will it take for Kayla to save $545? Okay, so let's think about what we could do. We know that $545 would be our money, right? That would be our term. So let's plug that in for a sub n. So 545 equals a sub 1 was 35 plus, we don't know our n, that's what we're trying to figure out, how many weeks is it going to take her, right? Times 10. So we need to solve this equation. Now I'm betting that most of y'all, because you love the distributive property, want to distribute, and I'll do that with you. That's cool with me. So 545 equals 35 plus, distributing this 10, right? 10n minus 10. Now, with that, I think we have some like terms that we could distribute, right? I think we could, not distribute, to combine. So with that, let's do that. We have a 35, we have a negative 10. Okay, so I'm going to make that 545 equals 25 plus 10n. We can subtract that 25 over. I've got 520 equals 10n. Okay, divide by that 10, meaning that n equals 52. Now, what does that mean? Well, ask how many weeks. So 52 weeks. In other words, 1 year. Okay, so in 1 year, she would have it. All right, so example 4. I want y'all to pause this, and I want you to work this problem out, and then we'll see if we agree. All right, here's what we got. Check it out. Reach out to your teacher with questions. There's a couple more if you'd like to try them for today. I wish you the best with the arithmetic sequences. Talk to y'all later.